Every part that passes inspection is only as true as the gauge that checked it. And a steel square slowly loses that truth, its reference edges wearing with every contact and rusting between shifts. The white alumina frame resting here is built to stay the reference. Hard enough that the faces it checks against barely wear, and a right angle that holds. Open with hardness around 1700 on the Vickers scale, hard enough that the reference faces resist the slow abrasion of repeated contact, holding their geometry across many times the working life of a hardened steel gauge. It does not rust, it draws no magnet, and it stays electrically insulating, so the surface that defines the reference is not quietly changing between checks. Dimensional steadiness rides alongside. A low thermal expansion, around 7 parts per million per degree, keeps the gauge close to its size as the room warms and cools, and the working faces are lapped to a roughness near or below 0.2 of a micron. Flat, defined edges that read the same every time a part is set against them. A square gauge does one demanding thing. It carries a true 90 degrees and a set of reference faces that other parts are measured against. Squareness is held to graded tolerances, the finest measured in single microns across the blade. And, like all dimensional metrology, every figure is referenced to a standard temperature of 20 degrees Celsius, so a gauge and the part it checks are compared on equal thermal ground. Keeping that angle true over years is the harder task, and it favors a hard, inert material. Because the faces barely wear and never corrode, the 90 degrees a steel square loses to handling and rust stays put. Stretching the interval between recalibrations and letting one reference serve far longer. Dimensions follow the inspection it serves. Overall size and thickness are set so the frame sits stable on a surface plate, the apertures sized to the features being checked, and the reference face is ground square and parallel to a chosen tolerance grade. The tighter grades holding squareness within a few microns over the blade. From that base, the format is cut to the task. Overall dimensions, the number and shape of the apertures, thickness, edge treatment, and the squareness or flatness grade are set to the parts being inspected and the surface they reference. Each one finished to a drawing rather than a stock size. The duty these gauges are made for is inspection. The squareness and dimensional checks that decide whether a machined part is in or out of tolerance. On a surface plate or in a comparator, a part is set against the gauge and any deviation from square or size shows up at once. The hard faces keep their defined edges through thousands of contacts. The inert body shrugs off coolant and humidity that rust a steel reference, and the non-magnetic surface leaves electronic probes undisturbed. Because the reference holds, the verdict the gauge gives stays trustworthy. The same check, the same reading, long after a steel one would have drifted out of grade.